All right, y'all. It's Tony Starks here to ask you guys some math questions. The question today is which line has more points? And so we have discussed this before, and we know that if I give you a line like the one in red, that we can say that the number of points that lie between 1 and 2 are an infinite amount of points. And this is easy to illustrate because if I had asked you how many points are there between 1 and 2, I'm sorry, what is the closest point to 1 um, that's greater than 1? Many would say 2 initially, right? What's the highest number that's greater than 1? Many of y'all would say it's 2, but we could argue that it's actually it could be 1.5, right? And if someone said it was 1.5, let's actually just even throw in 1.5 here. Say it's 1.5. Another could turn around and be like, well, you know what? I get this game, Mr. Starks. Let's get a little closer. Let's go with 1.1. And if somebody said 1.1, well, we could actually get even closer. We could say 1.01, 1.001, 1.00001. And this game keeps going on forever and ever and ever. So we know that between 1 and 2, there are actually an infinite number of points. We actually also know that between 1 and 4, by the same argument, there has to be an infinite amount of points. So a question emerges, which is, are there more infinities? Are there different sizes of infinities? So the question that we're asking specifically right now is, are there more points between 1 and 2 than 1 and 4? Or are there more points in 1 and 4 than 1 and 2? It stands to reason that there are more points between 1 to 4 than 1 to 2. So I think that's the most common thing. 1 to 4 is definitely a longer line than the line from 1 to 2. However, the interesting truth is that they are actually the same amount of points between 1 and 2 and 1 and 4. And since I am Iron Man, and I do have the Infinity Gauntlet, then it stands to reason that I'm the one to show you why this is the case. So to show you this, it's not actually that complicated. What I want to do here is first I'm going to take this line, this red line, and I'm going to bend it to form a circle. And then I'm going to take the blue line, and I'm going to do the same thing. I'm going to bend it and make it into a circle. And then I'm just going to take the red line, the red circle, which was once a line, and put it in the middle. And then I'm going to just, simply take lines and put them, grab the wrong point of the line. 1 second here. This line is not playing with me very well. Let's see if I can take it now. Okay, I'm going to take this line. Well, it wants to bend, so let's not make it bend. Let's take another line. This time I know it's a line because I chose just a line. And let's take it and let's drag it to the center. So let's say the center is about there. Now, what I want y'all to see is that, first and foremost, how many of these lines that I'm drawing right now could I extend from the center? And I hope that it would make sense that if you drew these lines out, that you realize that you could draw an infinite number that extend from the center. Why? Because we have every line has an infinite number of points, so then they have to also have an infinite number of lines that could extend out, because we keep drawing lines that extend out as long as these lines have an infinite, depth. So what I want to illustrate by doing this, though, is that for every line I draw out, they touch at one and only 1 point for each circle. So they only touch the circumference once. So what that means is that every line I draw out touches the red circle once. For every red circle point that it touches a blue circle point. So if you have an infinite number of lines that extend out, then this infinity has to be the same as this infinity. And that, my friends, is the power of infinity. To conclude, however, I want to make up one last point here, which is that if you're thinking all infinities have the same size, you're actually wrong. There are some infinities that are greater than other infinities. Perhaps in a future lesson, we'll discuss how that's so. Till then, stay safe.